These are non-motion elements to module to spur gears, system of gear teeth and beam strength. Systems of gear teeth. So basically, to create gears teeth, mainly three systems are used. They are 14.5 involute system, 20 degrees full depth involute system, and 20 degrees stub involute system. So first one, 14.5 involute system. Number of teeth to avoid interference is high because of low pressure angle. This process is obtained by gear generating process. So 20 degrees full depth involute system. Because of high pressure angle, number of teeth to avoid interference is less. These teeth are broader at root and stronger. Third is 20 degrees full stop involute system. In this system, the working depth is usually 20% less than that of full depth system, and addendum is made shorter. The advantage of this type of system are low production cost, stronger than full depth, less interference due to short addendum. However, with large number of teeth, full depth and 14.5 involute system perform better than stub. Beam strength of spur gear or Levi's equation. The beam strength of a gear is determined from an equation known as Levi's equation. The load carrying capability of the gears, as determined by this equation, gives satisfactory results. Lewis assumed that the load is being transmitted from one to another gear. It is all given and taken by one tooth. When contact begins, the load is assumed to be at one end of the driven teeth, and the contact ceases as it is at the end of driving teeth. Consider each tooth as a cantilever beam loaded by normal load Fn, as shown in figure, and is resolved into two components: tangential component Ft, the radial component Fr. The tangential component Ft induces a bending stress which tends to break the tooth. The radial component Fr induces a compressive stress. Of smaller magnitude, therefore its effect of the tooth can be neglected. Hence, bending stress is used for design calculation. The critical section may be obtained by drawing a parabola through A. In the tangential curve to the B and C. This parabola shown dotted line outlines a beam of uniform strength, but since the tooth is larger than the parabola at every section except BC, it concludes BC is critical section. The maximum value of bending stress at BC is given by sigma equals to m by I into C. M is sigma bending moment at FC, that is Ft into H. C is T by 2 thickness of tooth. I is BT cube by 12. B is face width of tooth. Therefore, sigma is Ft into HT by 2, BT cube by 12. Therefore, we have ft equals to sigma into b t square into 6h. Since t and h are variables which depends upon the shape of truth and circular pitch, the quantity t square 6h may be replaced by py, which is known as Lewis form factor. Therefore, the final strength from ft equals to sigma bpy. This equation is called Lewis equation for beam strength of truth. The value of y of various truth systems are sigma equals to 0.124 minus 0.684 by z. For 14.5, equation 23.115, y is 0.154 minus 0.912 by z. So these equations are given for reduced full depth and strength for equation of 23.116 and 23.117. Permissible stress in Lewis equation depends on material, pitch line velocity and load condition. According to the Barth formula, permissible stress sigma equals to sigma O into CV. CV is velocity factor. Sigma is allowable static stress. So velocity factor CV is 3 upon 3 plus Vm. Equation 23.134a. If Vm is less than 7.5 meters per second, 4.5 upon 4.5 Vm. If Vm is up to 12.5 meters per second, and to find Vm, we have formula is P pi d1 and 1 by 60,000 or pi d2 and 2 by 60,000. The our final form of Lewis equation is sigma ft equals to sigma bo byp cv okv. 23.93 question number.